Okay, thank you. Well, I'm delighted to be here. It's my first presentation with this institute. I was in the original British Foundry Institute and then obviously left to do other things, but now I'm back, happy to engage. So, firstly, why do we want a casting process and manufacturer to be approved? Now, I assume there's a good, I appreciate you all on mute, but I appreciate that there will probably be a good number of you that enjoy the odd cruise in normal times, whether it's the river, on the Rhine, in the Mediterranean, in the Caribbean, or some other luxurious location. So all these cruise ships are what they call classed, and there's a whole approval system relating to castings and forgings and steelwork and steel plate and wire ropes and chain cables. There's a whole structure of approvals for ships. But the point is, we need this qualification because we want the ships to be safe. If the ships are safe, the people will be safe. If a propeller falls off, then that gives a bit of a ship a problem, particularly in rough seas. Away from the home dock. So you can see this collection of photos, they're not all directly casting related, but it does show you what can happen. So ships sink. It's a sad, unfortunate fact. Accidents happen. They may have human factors involved, but they may have mechanical factors. And we want to minimize, if not eliminate, the mechanical factors of failure relating to, or under which we can control the manufacturing process to provide an approval system that's robust to give us safe ships and therefore safety of people. So just a bit of history here. I appreciate you might enjoy that. I've even got a historic ship tie on tonight with some 17th century, 18th century ships on. So Lloyd's Register was formed in 1760 and then it became a class society and has evolved over the centuries. It started off in a coffee shop. I wonder what the coffee was like at the time, but yeah, no cappuccinos, I assume. But so quite a setup, very long standing, and now we have class societies around the world doing essentially the same job, which is basically to get these manufacturing approvals and other control systems to support the marine industry. So the Lloyd's Register is part of IACS, or it's sort of under the International Classification Society system. So we're one of the main members, and then we liaise and we implement IACS policy, and we contribute to the IACS sort of technical pool of knowledge, and then we discuss and develop rules and systems from them or under them or in conjunction with them and other class societies. So it's quite a complex system. But it has got a certain robustness about it, and this doesn't cover castings. It covers steel plates, forgings, pipes and tubes, proving establishments, all a whole range of products. So I'm not going to list those other products because it's a bit beyond what we're going to discuss tonight. So these are some ships. Just a quick snapshot there. Obviously, there's the aircraft carrier. That's got quite a few approved castings on, and these other ships will have done if they're classed by Lloyd's Register. But of course, this approval system, each class society's got its own approval system, and I appreciate there may be some companies represented tonight that have got approvals with other class societies other than Lloyd's Register. That's fine. We won't argue about that. All doing a very important job. So with ship classification, there is this sort of, we have a design appraisal, we have a build function, we have an operate function, but a critical part of that is what we call material survey, where we oversee the manufacture of the material and then into installation into the ships in the yard and also for its maintenance thereafter. So this is just a sort of schematic of how that material survey system works. So you've got a whole number of functions here. You've got the material survey of the material going into a foundry, also a forge, for instance, or a foundry. Then we've got the survey of the manufacturing process, and then we've got the certification by Lloyd's Register when that product is produced under our approval. And then we have a regular triennial reassessment, and then that needs to be sort of agreed every 3 years for you to continue to have your approval certificate. Again, I'm just throwing you diagrams at the moment. It gets a bit more interesting with photographs and see it in the context of tests and things. So that says essentially what we've just gone. So we've got material survey, we've got manufacturer approval, we've got the rules. I'll explain that in a moment. And then we've got certification by Lloyd's Register. So this is just a few close-up pictures of some example castings. I actually took the top 3 when I was in Shanghai a few years ago. So you've got cast propellers, the hub, the not sure if you see my mouse cursor there, but you know, this rudder component and this rudder horn component here. Just looking at this diagram here, you've got the propellers again, rudder component, other components just above it. And then there's the machinery components, brackets. There's a whole range of casting applications in a ship. So for an application, for an approval, we are looking for essentially 2 key factors. We need to know that the company is capable of manufacturing the part, can satisfactorily inspect it, and satisfactorily test it. And then we also want to know that the quality of the product is compliant with the Lloyd's Register materials rules in association possibly with an international specification or a defence standard. So if the material casting alloy is not in the rules, for instance, if it's a nickel cast iron, then we would assess the approval to an international specification. Now, it's important to meet the surveyor. Now, these surveyors are engaged throughout the supply chain, at the foundry end, at the shipbuilding end, at the steelworks, everywhere. And I commend these people, the men and women around the world, there's thousands of them, and they're very bright people, they are very well trained people, and they do lots of materials courses because I happen to actually lecture on them. But you know, they do an important job, and they're no pushover in terms of material knowledge. They always consult when they have to, and they are heavily involved, and they visit the factory. So if you've got a factory in the UK, you will be visited by a Lloyd's Register surveyor at some point to help set up the approval, and then maybe to, or if that is set up successfully, then they come and assess and look at the testing and certify the product or sign it off. So men and women around the world going in factories and shipyards on a daily basis to keep an eye on the supply chain and then to certify products that are compliant with our quality standards. So this is a book you can download for free. Now, a point I would make here is that Lloyd's Register Marine and Offshore as an entity is getting separated from LRQA, and that means all the websites are going to be sort of split up, and so that's why I haven't given a specific web link for this book. But if you put into Google Lloyd's Register materials rules, then you'll be able to get into the latest or the current web link, and then you just sign up for a copy and you get your own copy to download. And it's very good for students because it gives lots of good summaries of materials. It's got, you know, steel make or steel plates, forgings, castings, aluminium castings, steel castings, iron castings, and copper alloy castings. So I recommend this. It's free. You do not have to pay for it, and it makes a very good item to read on your Kindle or your electronic reader or your tablet. If you're stuck in a hotel and you've got nothing else to do, I commend it to the house. So alongside the materials rules are another set of qualification documents, which are basically our guidance documents for specific approval groups or product groups. So we've got steel castings, steel forgings, aluminium plates, forgings and castings, and we've got copper alloys castings and iron castings, etc. So again, you really need to put it into Google to get the latest web link. That's still under development to get these really latest versions. So again, that's why I haven't put a web link in, because the company is changing it by the day. So again, if you go for a formal approval, you will need the materials rules that I just highlighted, and you will need the relevant document from this, what I've just showed you, what we call the materials and qualification procedures for ships. So let me just suck up some water here. So we've got approval schemes for steel castings, iron castings, aluminium alloy castings, copper alloy propeller castings, copper alloys for valves, liners and bushes, and we have a few approvals for nickel alloy castings. Overall, we have about 3,000 metallurgical manufacturing approvals at any one time. And for casting, we have about 880. So it's not the only game in town, casting. There are casting processes associated with steel making, aluminium refining and semi-finish manufacturing. I'm not going to include them in today's presentation. That is a whole new story. So in terms of casting approvals, I said there's 880 approximately worldwide, a few in the UK, not many. We've got cast iron, we've got about 380 worldwide. Steel castings, we've got about 360. Copper alloy valves, we've got about 180 approvals. And copper alloy propellers, we've got about 80. And aluminium castings, we've got about 30 to 40. Not very many, but we get a routine sort of turnover with those. And also nickel alloy, we've just got a few. That sort of seems to be sort of developing, but not in the same scale as the other standard alloys that we have. So molding processes that we see, there's no processes excluded. So we've got green sand, resin bonded sand. Yes, I do appreciate what resin bonded sand smells like. You know, same smell, different foundry possibly. Investment loss wax casting, either by robot or manual. Centrifugal casting, that's we've got a few of those, particularly for copper alloy tubes, liners for ship applications. Die casting, and we've even got approvals that employ the dieselmatic process. Again, there's a few photographs that I've taken in my travels, not the robot one, but it's always good to keep a camera with you when you visit factories, and they obviously agree for you taking the photograph. So just to run through the steel castings, alloys, we've got standards for in the rules for carbon, manganese and austenitic. And certain alloys are not listed in the rules, and we can cover them under the approval scheme. We have to evaluate them to an international standard. So some martensitic stainless steel is not in the rules, and therefore we'd have to assess that to a standard, an international standard or a project-specific standard. There's some other shots. We get up to maybe 400 tons for an approval application. So again, there's a large variety in weights from a few kilograms for investment casting to several hundred tons for ingots for forgings, possibly. That might be the application if it's that large. And then the thing I want to just emphasize is the running and feeding diagram on here. You know, if you're going to engage with us, you need to be open about how you calculate your runners and feeders, and you know, all the approval cards we will need to see the methods for. So if it's a case of I'm sorry, we think that's commercially private, then you know, we've got very discrete contracts that gives you know, confidentiality clauses appropriate to this. So if you don't want to disclose it, you don't want to discuss it even, you don't want to show us, then there's not much of an option to proceed. So I just thought I'd make that point. I think that's reasonable. I appreciate there's, you know, commercial advantages, but you know, we've got to have a unified system of approval. And if we sort of allow an approval through without looking at how you do it, then that's not sustainable. Okay, iron castings, there's a few views there. We've got grey cast iron, colloidal graphite cast iron, and compacted graphite cast iron. Number of approvals, as I said, about 380 kilograms to 250 tons sort of scale. Again, there's a few photos there just to give us a bit of context. Aluminium, we've got up to about 500 kilograms. I said about 35-ish worldwide. We do the number at the top, the 6A, is like a sort of our own housekeeping number. It's like our own internal list number, and it just helps us to sort of, you know, think about things and like, so you don't have to worry about the 6A or the 2 or the 5 or that. Yeah, do not worry about that. So copper alloys for propellers, about 75 worldwide. There's an approval certificate currently with a maximum weight of 150 tons. Obviously for quite a big ship, because we're talking about some of these ships are 200,000 tons plus. So they are big container ships that go around. They're just such, they're getting bigger, and the applications are getting wider with gas ships. In natural gas ships have been around the world. Loads of stuff being refrigerated and moved. So you know, things are moving at quite a quick rate, and of course we've got the new hydrogen. Well, not new, but obviously hydrogen's been around for a while, but it's getting very popular at the moment, and we're seeing approval castings coming through, or approval applications for that type of business. Copper alloys for valves, liners, and bushes. So this can be valves, although liners, this is the tubes, bush components. Again, we have up to 20 tons. There's sort of quite a lot of approvals for small valves of about maybe 100 kilograms, 150 kilograms. In fact, we're getting quite an interest in an increase in approvals for investment casting for valve components in several different alloys. So that's obviously a trend, not in the UK, but somewhere in the Asian subcontinent. This is nickel alloy casting. I just put it in for more context. That's the sort of component that we can approve. Obviously, it's part of a diesel engine system, and that is we've only got a few, but I think it's going to increase, and we have a system to sort of allow for that. And again, I would say that it would have to be, it is assessed against an international standard. So now I'm going to go on to how to get your approval. So you have to engage with the class society, in this case Lloyd's Register, Marine and Offshore, and they have local offices around the UK, in Liverpool particularly. We've got a Glasgow office, and there's other subdivisions and all that, but essentially you would liaise through the local office, which would identify either through your online inquiry, or you may already be connected to one anyway. So there's 3 parts to this that are absolutely critical. We have the manufacturing capability review, we have the test plan of the approval test castings, then we need a client to manufacture the approval test castings as per the test plan and as per the manufacturing information, and usually it's 3 castings per alloy. So if it's a grey cast iron, we want 3 castings. If you want SG castings, SG alloys as well, we want 3 colloidal graphite cast iron castings as well. And then at the end of it, the test result should be Lloyd's Register witnessed, and they should be everything should be submitted in a structured format. If you just throw us loads of information that's disjointed, that doesn't get you any quicker. In fact, it just mucks it up. If it's not structured, you don't have a test plan, you don't have a structured manufacturing documentation submission, then that can cause all sorts of problems, and that causes just more delays, and you don't want delays. We don't like delays, but sometimes we just have a lot of to-ing and fro-ing to get things right. Okay, so what's in the manufacturing capability review? We want to know everything. I think that's a fair comment. Organisation, ownership, history, staff, certifications, quality management, plant and equipment, processes and procedures, process flow sheets, runner and feeder design, process control, and laboratory instrumentation and calibration. So there's quite a few things there. There's nothing that's beyond anything that any company wishes to provide. It's standard information. We assume you may have 9001 certificate. That's great. Yeah, just show it to us. If you've got the health and safety accreditation, show that as well. We obviously like to see companies operating in a safe manner for our staff to visit. So that's also we need to consider, because our surveyors visit your foundry, and they witness your activities. So there's a few diagrams there. Sorry, there's a cat in the background that I'm worried about. So test plan. This is the sort of absolute critical central pillar of the approval submission. And this has got a few subtleties, and I'll go through this carefully, but it's nothing that isn't possible. It's not, none of this is too difficult that nobody gets it right. I mean, we've got 400 approvals on the books at the moment, each with a test plan. I've got 100 approvals on my books at the moment, each with a test plan. So it is important, and if it's not structured properly, then we have an argument, and then we need you to redo it and stuff like that. So you can save time and money by following our guidance, liaising if you've got any questions up front, and then right first time. So the approval scope requirement is critical. So this is a suggested structure. So we need a list of the approved test castings, the approval casting alloy, the casting weight, and the delivery condition. So that could be table 1. Then we need to know what the rules or specification requirement that is relevant, i.e. the chemical composition and mechanical properties. Again, you can insert this from the Lloyd's Register rules or an international standard, or your own project standard that you maybe wish to apply if it's for like a specific supply chain application. Then we need test sample information. So we need to know the location, the size, the shape, and you can do that with a sample diagram and dimensions. So we need to know where the sample is in the casting, or whether it's cast separately, and we need to know its size and shape. And we also need to know the size and shape of the final machined sample that is going to be tested. And I appreciate that, for copper alloys, the test sample or the tensile test results from a separately cast material can be significantly different from a sample produced from a casting. So we understand all that, but we want everything documented. If it's not documented properly or comprehensively, it just leads to more delays. And some of these jobs take many months to complete because there's a bit of toing and froing and agreement. But we need the test plan in advance, and then we like to agree the test plan before you proceed with manufacture. If you proceed to manufacture without us agreeing the test plan, then that's at your own risk if you haven't done enough tests, for instance. So we then need a list of the tests that you're going to apply or use to demonstrate your quality of your product. For example, we need chemical analysis, tensile strength, bend testing, impact, Sharpie that is, metallography, corrosion or destructive where it's appropriate, and non-destructive valuation, i.e. surface and volumetric, the old dye pen, volumetric, ultrasonic, magnetic particle, and radiography if it's appropriate and doable for the configuration and the alloy that you're casting. So again, we need to know what you're proposing, what tests you're proposing to carry out. Chemical analysis, tensile, bend. Now, I appreciate some tests aren't relevant to certain alloys, okay, like corrosion for cast iron, for instance. But where it's relevant, then you need to demonstrate that test is appropriately included. If you miss a critical test, you'll have to do it somehow. So bear that in mind. You want to try and find out everything that you should be testing for. Now, we ask for bend tests, which some class societies may not do so, or they may have a different policy on that. It's not for me to comment on other people's preferences, but the bend test is simple, and again, it's recommended to the house. And there's some diagrams there. I've given some examples from our rules about simple sample information setups, test casting dimensions. Now, just a point about weld qualification and NDE procedures. I've got a separate sheet for that in a moment, and that's also vital. If you think you're going to produce a casting for 800 kilograms and it's not going to need weld repair, then you really have to convince us that it doesn't need weld repair, and then we would put a weld repair not permitted on the approval certificate. So, and some on the other end of the scale, down at say 50 kilograms or 25 kilograms or 12 kilograms, it's not worth weld repair. So if the weld repair qualification procedure is not appropriately qualified and demonstrated to us, then we can't put it on the certificate. And obviously large steel castings obviously require a lot of weld repair on occasion. We also need casting drawing with dimensions, runner and feeder, and also runner and feeder diagrams with dimensions. So if you think your casting is so important that, or you don't want to show us a picture, then we're not going to go anywhere. Okay, we'll just put a stop and time to go. So if you give us all the information, we can progress it in quite a reasonable manner. Another sort of test plan, this is a sort of just an ad hoc collection of photos. We've got casting samples here, with a steel casting. We've got chemical analysis and optical emission. We've got Sharpie. We've got bend sample sizes and how a bend test would be undertaken. The running and feeding diagram, which I must emphasize is very important. Don't forget about that. We've got cast iron samples. So just a collection of photos, just to give it more context and a reminder that diagrams are good. Comprehensive information is good. If you release something out, that adds to the delay. So just another comment on weld repair. So we need the procedure qualification record, the welder qualification, and the welding procedure specification. And you need to account for any specific welding clauses and our materials rules applicable to alloy under approval, i.e. post-weld heat treatment for steel castings. I've got some very good colleagues. I'm a part of a small team. It's not just me doing this. As very skilled and people, a team with decades of experience with this sort of thing. And we've got welding specialists as well. And we've got non-destructive evaluation specialists. There's other metallurgists as well, wide variety of experience. But I come back to the point here that weld repair is important and it must be appropriately documented. That's if it's applicable to the approval. You need to tell us that clearly at the beginning. So non-destructive examination or evaluation, sorry, we need documents for this. So we need specific NDE procedure required for the approval product, and saying that you inspect to an international standard and that's it. That's just not going to get anywhere. Again, we need a specific NDE procedure that may refer to, might reference an international standard, may be based on an international standard, but it has to be relevant and applicable to the castings that you're seeking approval for. So we need NDE procedures, we need the NDE inspector operator qualifications record, and we need any calibration certification with the instruments that are used. And we need the demonstration of compliance with the LR rules on NDE or any applicable international standard used in combination. So normally, if we were in the pub, I would say any questions, but I'll carry on. So the third part of this TRIPOS system for approval submissions is the test results. So you've done the manufacturing capability submission, you've given us your test plan, which we've agreed, and you've gone away, manufactured the castings, you've molded them, you've poured them, you've fettled them, and I've been involved in all stages of it, so I'm very familiar how dusty it gets and how hot it gets. But the castings are there, and they have to be cut up and tested, or the separately cast samples are cut up and tested. Either way, we need a comprehensive submission of all the test results. Again, don't miss anything out. We need all the test reports. We need the chemical analysis, the mechanical testing, the metallographic reports, the corrosion tests, the test graphs, the heat treatment charts, the NDE reports, and any photos. Photos are good. And we also need to know the weight, but that you should appreciate that. And then just some examples of odd photos from test reports. So we need everything, and we want it in. We need it in a structured format. If it's unstructured and it's not labeled, you know, if it's not as basic as that, then we're dealing with hundreds of these reports on an ongoing basis, or maybe 400 at a time in the system. We've got 400 approvals at any one time. So this is a big operation, and we need our clients to cooperate with us to help you get your certificate at the end of the exercise. So this is the related approval page. So we've got the materials quality scheme, and then we have we also do approvals for metal stitching, which I'm actually the individual who deals with those. And so we do approvals for usually licensed processes for application of metal stitching to a lot of metalwork, including castings. So I'll leave that with you for information. The materials quality scheme is another level of approval above what we're talking about now, and it relates to, it's tied up with our approval scheme for machinery. So that usually or can involve diesel engine systems and other setups, other sort of machinery items like forgings and engines and things like that. So there's lots of applications. There are about 60 odd companies worldwide, mostly steel plate manufacturers, the occasional foundry in Japan. And what this means is we assess the company for its ability to certify or to provide the Lloyd's Register certificate with our badge on it, but to sign it off themselves. So it's quite a high level of responsibility, and it's audited appropriately several times a year with a triennial, every 3-year reapproval scheme. And as I said, that there aren't many around. You have to be, it's quite a serious approval to get involved with. It does involve a lot of scrutiny. We need to know all your quality schemes, your quality manual. We need to read that as part of the preparation. That's worth another lecture in itself. But if it's tied in a lot with the supply chain, so we need to tie up with the supply chain scheme as well. So we need to have sort of oversight of that, how that works. So what it is, I'll just skim back. I want to just appreciate, I don't want to make you feel dizzy, but I just want to go through a couple of critical points. So for your approval submission, we need a manufacturing capability review, we need a test plan, and we need the manufacture of pre-approval test castings per alloy. And that's per alloy group. So cast iron, SG iron are separate. Compacted graphite cast iron, separate. Carbon manganese steel, okay. Austenitic stainless steel, 3 separate castings, please. And then we need the test results to be Lloyd's Register witnessed. So you're under a lot of scrutiny here, but what would you expect? We need to make these castings by a process that is robust, that the qualification is robust, the assurance is robust, and therefore the ship doesn't sink. So it's as basic as that. We want ships to be safe. We want the passengers to be safe. I sail to the Isle of Wight several times a month, and I'm on a ship or a catamaran, but obviously it hasn't sunk yet, and I'm very grateful for that. But it comes back to the safety of the platform. We make the ship safe, we make the people safe. Okay, just flicking over here. Look, so test plan. I go on and on about the test plan, but it saves a lot of hard work if you get it right first time. So we have lots of provisions to look at. You know, when you go away, if you're going to do this seriously, please contact the local Lloyd's Register office. We are being restructured. I will say that the marine approvals are separate from the 9001 approval scheme. Some companies get a bit confused between the two, even today. And the other reminder is, of course, LRQA and Marine and Offshore are separating. We will be two separate entities owned by two separate organisations. Just another sort of feel-good item that may not know much about is that Lloyd's Register Marine and Offshore is owned by a foundation. And this foundation is one of the largest charities in the UK, and it gets income from the Lloyd's Register companies, but then it donates funds to good causes, such as that relate to the safety of people. So it might be a PhD study, it may be an educational bus going around Turkey, you know, giving education to school kids. So there's a lot of good causes that the business supports, because there's no shareholder making a profit. Now, I'm not criticizing companies that make a profit, because that's where our pension funds are invested, and we all like them. But in this case, we have sort of an ethos of serving this foundation. Recently I've been mentoring a PhD funded by the Institute. Sorry, not by the Institute, by the Lloyd's Register Foundation. And the person was funded to investigate a technical subject. In this case, it was cold metal spraying, which can be used to repairing castings. That's another talk for another day. So I commend it to the House. Any questions? Appreciate you all on mute.
Thanks very much, Clive. It was absolutely fantastic. Very, very thorough. Very, very captivated by your lecture this evening. I'm going to ask Richard to see if he's got any questions that have been directed to him, and then I'll open it up to the audience to see if anyone wants to ask a question.
No,
absolutely fantastic. So thanks very much, Clive, for your presentation tonight.
You're welcome.
We've got no. We've just had one question come in. Let me just put up the chat. It says, I guess we all assume that when we get on a ship, it's not going to sink, probably due in large parts to rules and regulations, including Lloyd's registers. Is ship casting regulation driven by government, insurance, the builders, or insurance companies?
Well, it's the whole system. You've got stakeholders, you've got ship owners, you've got and then you've got governments as well. So there's like a whole system of parties that are involved in like this loop system, I would call it. That's only an opinion. And so you have governments, you get what you call flag states involved. There's a whole lecture to be had about how that works, and I'm not qualified to really give that. But you know, the company, the business links in with other class societies. That links in under the IAC system. The IAC system has like a special structure of liaison and review of any new proposals. New proposals are not gone through lightly. They're reviewed time and time again, and with comments and stuff. So our rules are revised several times a year, and they're published about twice a year, or republished twice a year. And they are subject to continuous revision. The rules have been taken decades to evolve, and it's like any societal technical system. It takes time to evolve, and our rules have been evolving for decades. The society has been around for 200 and whatever it is, 80 years, 260 years. So it's not a sort of stationary point that we're at. It's continually evolving, and we have to continuously evolve with it. I mean, we've got all these new fuels. We've got natural gas liquefied. We've got hydrogen being liquefied and used. And we've got this energy revolution coming. We've got smart ships, unmanned ships, all sorts of innovation that we need to keep our oversight of under some sort of reasonable control and assurance. So another good word is assurance. So there's not an easy yes or no answer to the question. It's just that we're part of a structure of liaison and development with lots of different stakeholders. And there's, in actual fact, if you go on the IX website, you can actually download guidance notes and leaflets and things. So there's lots. I recommend that. There's a whole library of information about how the marine sector is structured and how IX manages its. Not a spokesman for IX, but it is good. The educational material for that subject. Is that helpful?
Yes, that's great. Thank you very much, Clive. You have a slide with your contact details on. If you could for people.
Yeah, there we go. So if you send me an email, it may take me a few days. I may not be in the office for a few days at the moment. So if you get that, I can send it to the local office. If you've got a technical inquiry that you're kicking off, then as much information as possible is good. You can't give us too much information. Like the castings, what do you want to do? What's the supply chain? What are they feeding into? Are they part of a greater supply chain assurance exercise? We need to know that. Are they going to be, I mean, you don't have to tell us if they're going to be approved by another class society, but a lot of approvals are sort of multiple class society at the same time. So yeah, we welcome your inquiry. As I said, I have to direct it. I can't answer it myself. I can give you the odd word, but I have to go. Well, it's quite appropriate to go for our local office.
That's great.
Wherever you are. So
that's great. Thank you very much, Clive. We've got no more questions in the chat. I see John Oakley's got his mic turned on. Have you got a question you'd like to ask, John?
No.
Well, as we've got no more questions in the chat, has anybody got any questions they'd like to turn the microphone on and ask Clive?
Clive, while we're waiting for any more questions, I'd just like to ask, sort of where do sort of foundries sort of fail first, and what's the most sort of common sort of
the other point I would
annoying you guys?
Thank you, Carl. What I would strongly say is that if a test is a failure, like it's broken off the shaft or the shoulder or the elbow, or it's marginal failure, don't submit it as if it's a pass. The failure is a failure, and we need 100% passing of all the tests. Not 2 out of 3 isn't bad like the Meatloaf song. It's just we need complete satisfaction and all the test results to pass the relevant quality standard.
Yeah.
And our quality standards for the materials that are in the rules are they're an open source document. There's no secret about them. And then we need the tests for Sharpie done at the appropriate test temperature. And then if the results are there's an issue with them, then you can either redo them or we discuss it with us, and then we can maybe pass the alloy that's passed and not the alloy that's failed.
Yeah.
So if you've given us the information, every information you can, the manufacturing quality, some management capability review information, which is like say everything, the test plan and the test results, plus photographs, and it's comprehensive, then we're in business. When you miss things out or you misinterpret what we're trying to do, then that causes delays and difficulties.
Sure. Thanks.
So we try and help. I mean, we're active. I'll say I'm only part of a small team, and there's everybody. We've got several metallurgists, around the world essentially, that can engage. But we're doing this with different countries all the time. China, Japan, Korea, India, Australia, USA, Canada, Portugal, Spain, France, Germany, Belgium, Russia, Saudi Arabia, possibly, Egypt. It goes on. I could just reel off more if I sort of thought about it a bit. So we're dealing with multiple national sort of beyond borders stuff, and the issues are the same. Manufacturing capability information, the test plan, the test results. I mean, our business language is English, so everything has to be submitted in English, and if it's in a different language, then fine, it needs to be translated. So the approval certificate is issued in English. So obviously we're quite lucky, because the business language is English and the team is based in the UK, and English is the working language. We've got other people that within our teams, it's multilingual in some offices, but essentially our approval scheme operates in English. Obviously it's fine with the UK. I haven't had one in Gaelic yet, or Welsh, but we are quite amenable to receiving material in different languages, as long as it's translated and we can understand what it means.
Yeah. One more question for myself. What are sort of the best systems for sort of casting identification? Because I know that that can be an issue sometimes, can't it? Sort of the method of identification, or sort of traceability. What's the sort of the best method?
Well, there is a Lloyd's Register stamp that you can apply, but I'm open to offers. It's not for us to recommend a particular issue, as long as the job to identify your product is for you, is it for the foundry? So we want it appropriately identified and appropriately certified and traceable. So how you do that is quite flexible. We have surveyor stamps and things like that, but that's just for our own certification assurance. It's not for it's not for you to do that, because obviously that's under the control of the surveyor. If you have a materials quality scheme approval, then you have the ability to issue certificates under our auspice, under our sort of supervision, if you like. But you have the authority then to issue the certificate with our badge on. But you have to have certain provisions on the certificate to say in the context of how that certificate is issued. Sorry, carry on.
Sorry,
I did see the other question come up briefly.
Yes, I have. We've just seen a new one pop up. If the foundry is a tier 2 supplier, who takes responsibility or gets surveyed for the NDE qualifications, etc.? The foundry or the machinist?
Well, good point. Let me just, if I may, if I go back to, hold on, let's expand that one. If I go back to the NDE page, get it right. So non-destructive testing, who is it? So you produce a casting and you're responsible for the delivery of that product, but you're not responsible for the NDE of it. I'll put that as a question. So if you use a subcontractor for a non-destructive evaluation, which you're entitled to do, there's no argument about that, but you still have to submit, you still have to be aware of what those procedures are. You need to give us those procedures and their NDE qualifications, and we will comment on them and review them appropriately. So if you are subcontracting any operation, if you subcontracted the casting, well, I'd have something to say about that. Is that really under control? Is that really appropriate? You're making the molds on one site and you're transferring 100 miles to cast on another. Probably not very efficient. Obviously, we probably wouldn't be too keen on that. In terms of subcontract NDE, that's perfectly reasonable, provided you give us the procedures and you give us the results. And as part of the inspection, if it is in like a premises, like a pretty close by your foundry, then it's appropriate for our surveyor to maybe go and view that and or witness the testing, or if it is anywhere else in the UK for that matter, it's for the surveyor to be engaged, to be aware of when the NDE is being undertaken, so he can go and witness and then countersign the certificate or the report. Does that answer that question? So if you're whatever tier you're in, if you subcontract something, we need to know about it. And the non-destructive testing, you are still responsible to give us that information. You don't just tell us to ring up the NDE supplier and then deal with him direct. No, that's not how we want to do it.
Clive, I have a bit of information about this question. So the question is to do with a foundry produce a raw casting.
Yeah.
That casting is then machined, rolled, potentially heat treated.
Yeah.
And then built into a marine diesel application.
Yeah.
So the question is, is it fine that the machinist is the only one doing the NDT on the product?
Well, it should be under appropriate control. Obviously, I can't speak for that individual case. But is that have the NDE procedures by whatever class society is involved here, or none at all? Well, okay, we can assume it's a class society involved. Have those NDE procedures been reviewed by a specialist of the class society? Is the NDE witnessed by a surveyor from that class society? So they should know that. You should know who's doing the non-destructive testing. You should know what process is being employed. If you've got subcontractors, then you should demonstrate appropriate control for your subcontractors, whatever the operation is, whether it's NDE or something else. And under 9001, there's provision for that anyway. And as part of your manufacturing capability review, if there was any, one of the questions is, do you have any subcontract activities? So subcontracting needs control. If it's NDE specifically, then we need to know all the procedures, all the respective qualifications, and we want to look at them, front end, not the back end. If it's a last minute job, then probably not the best way to go about it. So if you've got subcontractors, they need to be under control. NDE, we need to have oversight of the procedure, whoever does it, whether it's in-house or subcontracted. And if it's subcontracted, you're still responsible for the foundry is still responsible to give us those procedures. Don't tell us to go and find them from this subcontractor down the road. We need you to tell us what you're doing, even if it's done by a subcontractor. I think that's only fair and reasonable.
Well,
Thanks.
I think you've been very thorough in your answering your questions. So.
Yeah, we have another interesting question that's just come in, and it's sort of I guess it's horizon scanning or crystal ball, depending on which sort of particular bent people have towards these things. In the carbon-free future, when will shipping not be using diesel?
Oh, wow. Well, I've got a tie here with some 18th century ships on, so we could go pretty soon if we just use the sails, couldn't we? Probably not. But there are some technology innovations relating to the use of wind from the weather. Could I answer that question? Probably. It's a fun one. We have lots of engagement with these environmentally friendly initiatives such as hydrogen, liquid natural gas. So, and obviously some ships are using natural gas, aren't they? Already. So it's, honestly, fair cop, I can't give you a good answer for that. The answer is when, I mean, things are accelerating. How realistic some of the aspirations are at the moment, such as getting rid of all petrol cars by 2030 or new ones. That's quite a development, that is. I mean, that means all of us now have to think about what we're going to do after the next car. Yeah, if we're reaching retirement, shall I get a car to last me 15 years? Get a diesel then? Oh dear, might be expensive, or they might not be around in 5 years. Yeah, incredible questions and incredible technical developments that need to happen. seem to be gearing up for development. When we look at the hydrogen applications, all these other sort of possibilities, it's an exciting time, but it's a bold time. There's a lot of politics involved, and a lot of money is going to have to be spent to develop these systems. I mean, how many castings will we need in a battery-powered car? Because it's going to be heavier. Is that going to change the casting design? I raise a question. I wouldn't expect an answer today. Okay, any more questions from that? Any sort of is that a reasonable response? Are you happy with that?
It is indeed. Thank you very much, Clive. We have no more questions, so I'll hand everybody back over to Carl.
Yeah, thanks, Clive. I've really enjoyed your presentation and lecture tonight. Slightly different from the norm, and actually I think it's appealed to lots of foundries and lots of different applications, lots of different operations around the UK. So thank you very much for the preparation of a very thorough and enjoyable lecture. I'd like to hand over to my colleague Mark Holliday for the vote of thanks.
Clive Arnold, thank you very much for joining us. It was in fact a sort of interesting it ends up being a very diverse sort of subject, different particular castings needing to be certified for marine. And I'd like to thank you for coming here tonight and spending your time with us and educating us. And I'd like to thank, on behalf of the Birmingham and Coventry Institute of Cast Metal Engineers, I'd just like to show you a round of applause. Thank you very much, Clive.
Thank you. Thank you.
Yeah, cheers, Clive. And I'm sure that we're going to be seeing more of you in the future. Talking to you prior to the presentation, I know you've got lots of ideas and thoughts, and I'm sure sort of colleagues online tonight will get in touch, which will ask further questions. But I know in the industry, there's going to be lots of people who sort of like to talk to you or listen to you again in different forums. But it's been really interesting. So thank you very much for presenting. It's been a huge privilege. And I'd like to wish everyone happy Christmas, and I hope you all have a great Christmas break. And